In this video, I'm going to cover the LTV-1200 mechanical ventilator and all the vent settings in great detail for you, the paramedic. Let's get to it. At the top, you can see the airway pressure meter. It visualizes each breath the patient receives, leaving a dot at the peak inspiratory pressure point. You will note that the meter reaches into the negative range down to -10. If you see the meter move in that direction, it indicates the patient has drawn a breath on their own. The vent will sense when the patient does this and will deliver an assisted breath if your settings allow. Below that is the LED message screen. It displays setup information when the vent is first turned on. Once the vent begins to operate, you will see information about different breathing metrics scroll through. This will be where any alarm information is displayed. Below that are the vent setting features. Let's go through them one by one. Respiratory rate. You better know what that one means. Come on. Tidal volume. What volume of air moves into and out of the lungs on each breath. Right next to tidal volume is pressure control. Currently, it is dimmed out, which means it is not in play. This is because pressure control is an alternative way of delivering a breath to the patient. When the vent is set up for a new patient, you must select the patient category before it starts. If you choose the pediatric or infant category, the vent will start in pressure control. If you choose adult, then breaths are delivered by tidal volume. The reason for this is calculating the lung capacity and tolerances for children is not as easy as for adults. Pressure control will inflate the lungs until a compliance limit is reached. When that pressure is met, the vent will cycle to allow the patient to exhale. Take a normal breath and hold it right now. Your lungs are probably at around 20 to 25 centimeters of water pressure. I bet you can still take in more air though. Try to stack breaths on top of the one you're holding. It's uncomfortable, but you can sense there's more capacity than what you normally use when you breathe. You probably got your lungs up to 40 centimeters of water pressure, and that's as far as you want to go. For adult patients, that's where the high pressure limit is set. Once that limit is reached, the vent will not cross that line. It's an important safety feature. To switch between tidal volume and pressure control, you can toggle the button here on the bottom row next to the power. All right. Next is inspiratory time. This is how long the inhalation breath should take. It's around a second or a fraction of that. Remember, you don't need to figure out what settings the patient needs. This information will be given to you by respiratory therapy. Oxygen concentration is next. Most vented patients are less than 50% to avoid building up to toxic levels. This is one setting that I would play with while transporting if my patient isn't saturating well, only because our transport time happens to be in such a short window. Sensitivity is next. The best way to explain this is how much of an effort the patient needs to make to draw a breath before the vent will trigger and assist them. You will see this in action on the pressure meter. If sensitivity is set too high, then merely jostling the patient will create enough negative pressure to trigger an extra breath. Too low, and a weakened patient won't get a breath delivered. Over here in the corner, like a redheaded stepchild, is PEEP. I don't know what PEEP did to get excluded from the rest of the vent settings, but it doesn't seem fair. PEEP is incredibly important. Positive and expiratory pressure. This keeps the patient's lungs pressurized even after they exhale completely. That way, when the next breath comes in, those spaces don't have to be reopened. In a spontaneously breathing patient, this is what CPAP and BiPAP do. When the vent is started, no matter the patient category, the mode will always default to AC. This stands for assist control. Early vents were control only. They would deliver a breath on a time schedule. If the patient was stressed and wanted more oxygen, well, you try sucking air through a 6-foot length of garden hose. Tell me how it feels. You won't be able to do it for very long before you pass out. Modern vents are able to sense when the patient is taking a spontaneous breath and help out. This is called assist control, the most common mode of ventilation. Most patients who are placed on assist control on a ventilator will die on assist control. That's just reality. Healthy people don't go on vents. SIMV mode is for patients who are improving. You may have heard the term weaning off the ventilator. SIMV will allow the patient to breathe at their own rate and depth, provided they stay above the minimums built into their vent settings. We still need to plug in vent settings in case they relapse and go back into failure. When you toggle the mode button over to SIMV/CPAP, a new vent setting will light up. This is called pressure support. Pressure support only engages when SIMV is selected. It's related to PEEP, but instead of providing pressure at the end of the expiration cycle, it provides pressure at the beginning of the inspiration cycle. Basically, it helps the SIMV patient move air through the circuit, and in some cases, the ET tube. SIMV shares this spot with CPAP, which you may find odd. These are two distinct ventilator modes. When there's a respiratory rate set here, and the CPAP SIMV light is on, the vent is in SIMV mode. If you dial the respiratory rate all the way down to dash, now you're in CPAP mode. Here at this agency, we do not use the ventilator for CPAP delivery in the field. In the hospital setting, no one is going to fool with CPAP when the vent is capable of delivering BiPAP. So really, you only have two modes to worry about for an intubated patient, either AC or SIMV. The last mode here is NPPV. It stands for non-invasive positive pressure ventilation. You may not know this, but the term BiPAP is trademarked. If you put the term BiPAP on your machine, you will need to pay a royalty to the owner of the trademark. But you can call it something else, mechanically do the same thing, and save a lot of money. I'll do a separate video on BiPAP with this ventilator. So moving on. Inspiratory, expiratory hold and manual breath are buttons we don't need to fool with. The respiratory therapists and physicians use these to evaluate the patient. Leave them be. Low pressure O2 source likewise can be ignored. Control lock is a simple way to prevent any of the settings from being changed without turning the lock off first. Again, not something that really can happen accidentally. These vents may be used in the home setting, and this is more of a child lock. Before I get into the alarms, I want to direct you to the silence reset button. When an alarm occurs, there's an audible alarm and an alarm message. If you push the button here once, the audible alarm is silenced, but the message will still flash. To clear the message, you need to push the button a second time, which puts the vent back into normal operation, if you fix the problem. If you didn't, the audible alarm will begin again. Always keep in mind that the after effects from the condition that caused the alarm may persist. Have you ever been startled by someone who played a prank on you? Even after you realize that you're not in danger, your heart rate may still stay elevated for a little before you relax again. Sometimes you have to give the vent time to calm down. All right, let's talk about alarms. There are 3 limits that are defaulted to the patient category that you start the vent in. For more help with troubleshooting alarms on your ventilator, watch my video on the DOPE acronym. High pressure. This limit is set so that the lungs are not in danger of hyperinflation if too much volume is delivered. When the vent senses the pressure has reached the set limit, the alarm is triggered and the inspiratory cycle immediately switches to expiratory. This alarm can trigger if there's an obstruction in the circuit or in the patient's airway that creates a bottleneck or choke point. Imagine a hose with a kink in it. Secretions may build up in the airway and need to be suctioned. A dislodged endotracheal tube pushed into the right mainstem is going to create a high pressure situation. Low pressure. This limit is set to alert you when there's a loss of pressure in the circuit. Basically, the air is not staying in the circuit because there's a leak somewhere. Maybe the circuit has become disconnected from the advanced airway. Maybe the ET tube has dislodged. Minute volume. First, minute volume is a calculation of the respiratory rate times the tidal volume. For an adult patient, the vent defaults to 12 breaths a minute and 500 tidal volume. This means the minute volume is 6,000 milliliters, or 6 liters. Over the course of a minute, 6 liters of air volume are pushed out of the vent. It should follow that close to 6 liters of volume therefore leave the patient over that same time frame. These numbers are not usually exact, but if significantly less air is coming out of the patient than the amount going in, that indicates there's a problem. The minute volume limit for an adult patient is set to half the programmed amount. A minute volume alarm could indicate that there's a small air leak in the system that's not enough to set off the low pressure alarm. This part is important. The alarm limits do not change from the default settings when you adjust the respiratory rate or the tidal volume. If there's a big change in respiratory rate or tidal volume, you will need to do the math, recalculate the minute volume limit, and make the adjustment. A word of caution about alarms. Sometimes it's just the ventilator being temperamental. You may remember your paramedic instructor telling you to treat the patient, not the monitor. In this case, treat the patient, not the ventilator. When an alarm goes off, your first move should be to silence it and consider the message. Then, look over your patient. Is their chest rising with each breath? How does their color look? Is everything okay? Next, look at your monitor. How's the capnography look? What's their CO2 at? What's their SpO2 level? Still within expectations? Look at the vent circuit. Check your connections. Now that you've evaluated, consider the possibility of a false alarm. Clear the alarm message if it hasn't gone away on its own. If it keeps recurring and you're convinced the patient is fine, for your own sanity, you may need to adjust the limit value to stop the alarm from triggering. This needs to be documented and you should discuss what happened with the receiving respiratory therapist to see if they can identify the reason. Okay, this was a long one. Thanks for hanging in there. Please let me know if this was helpful for you in the comments below, and be sure to check out the rest of the videos in the folder.